Hello, my name is Hamid, and I'm from Foreign High School. And this is gonna be like super close to midnight because my mentor let me know very late, so I had to design this within 24 hours and build it. So um, let's start off. What is a model rocket? Rocket is like a lightweight and small rocket, and it has real rocket engines, but it's like a fraction of the size, and it is mainly for hobbies, science, and education. And like the engines range from class A to class O, and A is the weakest and O is the strongest. And with model rockets, when the rocket hits the apogee, which is the highest point of its flight, it deploys the parachute system. And this is either with a small explosion, a carbon dioxide tube, or in my case, I designed it with a spring. And I'm going to talk about how the spring is better than the other options. So the major problems with parachute systems now is that it can have wrong timing, because most of the time people use the application that's called Open Rocket to see how long it takes for the rocket to reach apogee, and then they program their flight computer to set off at that time. But this is like unreliable because the weather changes every day, and the weather can affect how long it takes for the rocket to go, or like every motor is different, so you can't really be for sure about when it's gonna go off. And it's non-reusable. Like the explosion one, you have to buy the new explosion kit, and for the carbon dioxide, you need to buy a new carbon dioxide tube every time you want to launch the rocket. And I did research, and there was like a bunch of different systems, and fun like studies from Delft Aerospace and even NASA's older ports showed that the systems are unreliable and they aren't always perfect. And like even more problems, it can like melt or burn the plastic and the parachute. And on the Military University of Technology in Poland, they were looking at the carbon dioxide powered systems to push the parachute out. That avoids the heat problem, but they're expensive and they are non-reusable. And spring-loaded systems, they're still not too cheap, but they're super reusable. Like every launch, you can use the same exact system. All you need to change is batteries, 3 AAA batteries, like very once in a while. And my hypothesis, it was, if a spring-loaded deployment system with a G sensor is used in a model rocket, then the parachute will deploy more quickly and consistently at apogee compared to a traditional engine ejection charge and a carbon dioxide tube system. And because the stored spring energy can be released more reliable and without relying on heat or combustion, and does not rely on a timer. And my solution is that I designed a parachute system, and it works on the rocket's tilt, like a G sensor, and springs. And it converts the spring potential energy into linear kinetic energy when it goes off. And it is built with a metal leg, the aluminum rod, the bowl, and then 2 plates, and then the middle plate connecting it all. And it has the flight computer, and I use a microbit V2 for the flight computer. I used alligator clips with the pigtail ends to connect it to the servo motor, and it's right here. And here's the battery pack. And how to do it is you push down when the rocket is facing up. You press the button and it locks the system. And let's say the rocket launches, and then it goes to the side like that. And this works in every direction. I'll show you guys. Let's say the rocket goes like that, and as you guys can see, it's reusable because I'm like loading it every single time. And let's say it tilts this way, and then finally let's say it tilts this way. And the materials I used were the white PLA filament. I used the aluminum rod. I used two 4-inch springs. I used a 3-volt micro servo. I used a microbit V2 for the flight computer, a battery pack with the USB port, 3 alligator clips, 1 short micro USB cable that is connected to the microbit and the battery pack, and I used like a little metal sheet to make this, and I used nuts, I used bolts, and I used washers, and to like drill holes I used a drill and drill bits, and to design this I used SolidWorks 2025, and I made this separate and I made this as one piece, and I used OpenRocket to test out the timer method, and my results, the deployment system with like the carbon dioxide, it like you need to buy tubes every time and you need to spend more money, and when I tested out the explosion deployment, the heat from the explosion causes damage to the 3D printed filament because this can melt, and it pushes like the spring because the explosion goes in every direction, but the spring it does not get attached anywhere because once you do, the parachute goes on like this, and once it reaches apogee and when it deploys, it pushes the parachute, and that also pushes the nose cone off and deploys the parachute, and it worked perfectly fine, like you guys saw, and we don't need to replace anything or buy new parts for it every time we want to use it.